In March 1966, the Arctic Institute of North America was asked by the Advanced Research Project Agency if it would be possible to establish a small scientific station on the Greenland ice sheet during the coming summer for the purpose of recording internal seismic noises due to movement of the ice sheet and other natural phenomena, in connection with studies to detect natural and man-made seismic disturbances. To accomplish this, seismometers would have to be placed in precise pattern into hard blue ice. From this inquiry, Project Blue Ice came into being, with the cooperation of the 17th Troop Carrier Squadron of the Alaska Air Command, the Geophysics Division of the Air Force Office of Scientific Research, the Geodetic Institute of Denmark, and the Arctic Institute, working with the Geotech Division of Teledyne Industries. In early June, a small group of scientists and technicians under the leadership of Mr. Ralph Lenton of the Arctic Institute landed at 78 degrees north, 39 degrees west in a ski-equipped 17th Troop Carrier C-130 to begin setting up the station. By mid-August, the station was established and the program was well underway. Preliminary results were encouraging, and on August 19th, Danish and American officials met on the ice sheet for a dedication ceremony to name the station for Inge Lehmann, a noted Danish seismologist of the Danish Geodetic Institute. Mr. Robert C. Fahler of the Arctic Institute, Dr. Erik Jortenberg of the Geodetic Institute of Denmark, Dr. Harry Sonneman of the Advanced Research Project Agency. Before this happened, a tremendous amount of organization and work was accomplished. Equipment and supplies were assembled at Bolling Air Force Base for shipment to Dover Air Force Base, Delaware. Then loaded aboard a military airlift command C-124 and flown to Thule. There transferred to a ski-equipped 17th Troop Carrier C-130 for delivery near the center of the ice sheet, 400 miles away at 8,000 feet elevation. 2 completely assembled trailer units for living, working, cooking, and eating, a rotary drill rig with all supplies, 2 motor toboggans and a small bombardier for transportation on the surface, 1 16 by 24 Jamesway shelter, 2 15-kilowatt diesel generators. All were airlifted in 8 initial loads totaling 60 tons of equipment, housing, food, and fuel. 5 additional resupply flights were made during the rest of the summer. With the assistance of the crew personnel of the 17th Troop Carrier Squadron from the Alaska Air Command, the station was set up. After ensuring the comfort and safety of the personnel, the work of laying out the pattern for the holes to place the seismometers was begun. Mr. Richard Regal, the Arctic Institute staff glaciologist, was in charge of the initial phase of this work. Dr. Wilfred Weeks and Mr. Stephen Mock of the Cold Regions Research and Engineering Laboratory of Hanover conducted a tellurometer survey for precise determination of the pattern. One vertical and 2 horizontal seismometers were placed in a surface pit at a depth of 15 feet for the purpose of short-period signal detection. A PE-23 semi-armored multi-cord cable was laid from a recording room at the station to each drilling site, approximately 2 kilometers. A Polaris snow traveler was used for cable laying. The cable was heated with a Herman Nelson to give it flexibility in the cold air. An Acker rotary drill powered by a Perkins diesel engine to ensure having more than enough power at 8,000 feet, and modified by the addition of an auxiliary transmission to provide low drilling speeds, was moved to the drilling site. Using its own winch, the drill rig was maneuvered into position for drilling the first hole. A 7 7/8 inch by 6 foot auger, patterned after the Cold Regions Research and Engineering Laboratory's hand auger, was used for drilling the first 50 feet, which was encased with 6-inch plastic well casing. Beyond 50 feet, a 4 7/8 inch by 6 foot auger was used down into the hard blue ice. Drilling continued until an ice density of 0.83 was reached, which at this location was at a depth of approximately 200 feet. Four holes were drilled, one at base camp, 3 in an equilateral triangular pattern, 2 kilometers from the center. Ice cores were preserved for later study. As the holes were completed, a junction box was placed at the top of each hole of the well casing for connection of the well cable to the ground cable. The seismometer designed and manufactured by the Geotech Division of Teledyne Industries was carefully lowered into the hole by Geotech personnel. Lane Churchman of Geotech set up the electronic equipment to record the seismic information. This information was recorded on magnetic tape for analysis by Dr. Edward Dews at Garland, Texas, while a visual record was made for field evaluation. Preliminary evaluation showed the natural background noise level to be extremely low, indicating a very promising location for additional seismic studies. Detailed analysis of the magnetic tapes has since confirmed this opinion, and it has been decided to continue seismic recording throughout the winter. The existence of Inga Lehman Station and Project Blue Ice made possible opportunities for additional environmental studies in several scientific disciplines. Meteorological records were kept and synoptic weather reports were transmitted daily to the Air Weather Service at Thule, which provided important additional forecasting information. 10-meter snow pit studies show a mean annual temperature of minus 32.5 degrees centigrade, indicating that Station Inge is in a position to record the lowest temperatures in the northern hemisphere. Ice cores, which were byproducts of the drilling, were preserved and shipped to the Cold Regions Research and Engineering Laboratories in Hanover, New Hampshire. Dr. Johannes Wilhelm of the Danish Meteorological Institute built a non-magnetic laboratory to conduct experiments in the fundamental properties of the Earth's magnetic field. These records depict the intense magnetic storm of September 1966 against the normal daily records taken at the station. Two tons of snow at an age depth prior to 1950 were collected from a tunnel by Arctic Institute personnel to be sent to Thule for preparation by Dr. Heinrich Clausen of the University of Copenhagen for final silicon-32 analysis at Copenhagen by Dr. W. Dansgaard. Project Blue Ice has been successful because of the cooperation of the Danish and American scientists working under a program sponsored by the Advanced Research Project Agency under the direction of the Geophysics Division of the Air Force Office of Scientific Research and the cooperation of the Air Force Technical Applications Center, Thule Air Force Base, and the Alaska Air Command. Station Inge will continue to operate during the Arctic night through May 1967.